Hello and welcome to another online video lesson for GCSE Physics. Today's learning intention is to know what a renewable energy resource is. So, as always, we're going to begin with a quick task, a fish, dog, elephant task. I would like you to pause the video and have a go at each of the questions, answering in as much detail as you can. The fish question is, why would lubricating the wheels of a scooter help the boy on it reach a faster speed? For the dog question, I would like to define the term specific heat capacity, and for the elephant question, I would like to list 4 stores of energy, please. Pause the video and answer each question in as much detail as you can. Okay, so let's go over the answers to the questions. The first one, about the boy on the scooter, has got 2 marking points to it. First of all, we could say that it will reduce the amount of friction between the wheels and the bearings, or just basically reduce any amount of friction will be fine. The second mark, that means that less energy will be dissipated to the surroundings. Okay, you could also have said instead, if you didn't want to say there'll be less energy dissipated to the surroundings, you could alternatively have said, and so we will have more energy in his kinetic energy store. That would be fine too. Question number 2 was to define the term specific heat capacity. Well, specific heat capacity, word for word, is the amount of energy needed to increase the temperature of 1 kilogram of a material by 1 degree C. And then finally, I asked you to list 4 stores of energy. There are, of course, more than 4 stores, but the examples that I've given are kinetic energy store, thermal energy store, elastic potential energy store, and a chemical energy store. If you haven't got those, you could also have said, for example, gravitational potential energy store as an alternative as well. So, success criteria for today's online video lesson is to know the difference between renewable and non-renewable resources, to explain the advantages of each renewable energy resource, and finally, to consider where a wind farm may best be located, whether it be onshore or offshore. Okay, so let's consider what an energy resource is in the first place then. Obviously, as long as there's been technology and anything that we require power for, we have needed to be able to harness energy. Take, for example, steam trains. You know, they don't run on thin air, do they? They need a fuel to get energy from. You'll know, of course, if you've ever seen a steam train, that they run off coal. They put coal into a big furnace and that is burned to get energy from. Now, unfortunately, we are running out of coal, and that's what makes it a non-renewable energy resource. A non-renewable energy resource is one that will eventually run out. Coal is, of course, one example, but you could also consider oil to be non-renewable and natural gas as well, because they will all run out. There is also uranium, plutonium that we use in nuclear fuels. They are non-renewable as well. Therefore, we have a problem, because if we eventually run out of fuel, then we won't be able to have transport systems, we won't be able to have cars, trains, planes, or anything like that. So scientists are, of course, working on developing renewable energy resources. Now, a renewable energy resource is one that will not run out because it is replenished as it is used. Examples of renewable energy resources might be geothermal power, which is what I've got pictured there for you on the board, but also biofuels and wind turbines would also be considered renewable. We're now going to have a look at the advantages and disadvantages of some different non-renewable resources and renewable energy resources, as well as considering how each one works. I will talk you through the slide, of course, but you may wish to pause the video at various points to write down the key information, because all of this is important. So the first thing that we'll look at then are the fossil fuels. There are 3 fossil fuels. They are coal, oil, and natural gas. The way they work is all the same. They get burned, and when they are burned, they release energy. That process, of course, you'll know from chemistry as being combustion. When the fossil fuels are burned, energy that gets released is used to turn water into steam. The water is boiled and so therefore changes from a liquid into a gas. That gas then turns a turbine, which then drives a generator, and when a generator is being driven, that produces electricity. Now, there's lots of advantages of using fossil fuels, of course. The biggest one is, and probably the most important one on why they are so widely used, is because they are reliable. They don't depend on the weather conditions, they don't depend on anything, they can be used at any time. Therefore, we can generate electricity continuously 24 hours a day. Another advantage of some of the fossil fuel stations, like gas stations, is that gas stations have a short start-up time. What that means is if there is a sudden increase in demand for electricity, then what we can do is turn on a gas power station or increase the output of it at times of peak demand to meet the demand. However, things like coal and nuclear stations do not have a short startup time. It takes them a long time to change their output. Now let's look at the disadvantages then. First of all, when we burn any of the fossil fuels, carbon dioxide gets released to CO2. Now when CO2 is released into the atmosphere, that can cause global warming, and you'll know from your chemistry lessons, of course, and maybe your geography lessons as well, that global warming is a big issue because it causes ice caps to melt, sea levels to rise, etc. Sulfur dioxide is sometimes released as well, SO2. Now, sulfur dioxide is very bad because that can cause acid rain, and the effects that that can have on ecosystems can be quite catastrophic. As well, particulates can be released, and particulates can cause something called global dimming, which would be a big disadvantage. And then finally, and again, probably the most important one, is the fact that they're actually non-renewable anyway, so eventually we will run out of the fossil fuels. Now let's consider nuclear power then. So nuclear power stations use enriched uranium or plutonium as a source of fuel in the power station. The isotopes that are used are uranium-235, uranium-235 and plutonium-239. What happens is that the uranium or the plutonium is used in a process called nuclear fission. Now, nuclear fission you will study in more detail if you do triple science, but all you need to know if you're doing the Trilogy Award is that during nuclear fission, the uranium nucleus splits up, and when it splits up, it releases energy, lots and lots of energy. The advantages of using nuclear power stations is that there is no carbon dioxide or any other greenhouse gases for that matter released. Therefore, of course, it will not contribute to global warming. Again, they are reliable and the electricity can be continuously generated, and much more energy is available per kilogram of uranium or kilogram of plutonium than would be available from each kilogram of coal, oil and gas. Therefore, we can actually use the term energy density, and you might see that in some of your revision guides. We can say that nuclear fuel has a high energy density, meaning we get lots of energy per kilogram of it. The disadvantages of it ultimately come down to safety. Used fuel rods contain radioactive waste which need to be stored safely deep underground, and they remain dangerous for centuries. Okay, so now let's move on to the renewable resources, and we'll start with biofuels. As you can see from the picture on the board, biofuels essentially come from plants. Plants are used to make biofuels by growing them, first of all in a field as shown in the picture, and then they get dug up, harvested by a farmer, and then processed to make a biofuel such as biogas or biodiesel. Now, the biggest advantage of biofuels is, of course, the fact that they are renewable. A renewable resource is one that gets replenished as it is used and therefore will not run out. What this means in terms of biofuels, of course, is that once the plants have been harvested, new plants can be planted and can be growing whilst the biofuel from the plants that have just been dug up is being used. Now, biofuels do not use fossil fuels, and so preserve these fuels for other uses, which is a big advantage because obviously we have limited amounts of them. And biofuels are also carbon neutral. The plants absorb carbon dioxide when they are growing. Of course, they do that for the process of photosynthesis, but they will, of course, release the same carbon dioxide back into the atmosphere when they are burned. Therefore, even though carbon dioxide is put into the atmosphere when they're burned, because they've taken that same carbon out of the atmosphere whilst they were photosynthesizing, we say that they are carbon neutral. To be truly carbon neutral, though, things like harvesting will be done, need to be done using a renewable energy resource that doesn't release carbon dioxide. Now let's look at the disadvantages of biofuels then. Firstly, growing plants for biofuels takes up large areas of land which could be used for other things such as food crops, and biofuels release less energy per kilogram of fuel than the fossil fuels do or nuclear fuel, meaning that they've got a low energy density. Now let's look at geothermal, which is shown in the picture there as essentially just steam rising from a lake. So basically it works by having hot rocks underground. These hot rocks may be radioactive, buried deep quite under the ground. We pass cold water down to the hot rocks under the earth. The hot rocks boil the water to produce steam, turning the liquid into a gas, and that steam produced drives a turbine which then generates electricity. So, the advantages of using geothermal power stations. Well, for a start, they've got no fuel costs because obviously those hot rocks already exist. So once the infrastructure is in place with the pipes to put the cold water down and then the steam to be transferred back up, there is no actual extra costs needed, so no fuel costs whatsoever. They're of course renewable because the fuel is being replenished, it's never going to run out. Geothermal power stations do not use fossil fuels and so preserve these fuels for other uses, and because they don't produce carbon dioxide, they will not contribute towards global warming. Could also point out that they don't use sulfur dioxide either and so won't cause acid rain. The disadvantages of using geothermal is that most parts of the world do not have sites that can be exploited for geothermal power. It of course depends on where you've got the hot rocks underground that can be exploited. Now let's look at hydroelectric. Hydroelectric or hydroelectric dams basically work by storing water high up in a reservoir. When the electricity is needed, the water is then released and will flow down a hill. As the water flows, the gravitational potential energy stored in the water will of course be transferred to a kinetic energy store of the water as it's moving, and then that kinetic energy from the water is going to cause a turbine to turn, which will spin a generator to generate electricity. Now the advantages of this is again that there are no fuel costs whatsoever. Of course that water ends up in the reservoir just simply from natural rainfall. Hydroelectric power stations are reliable and they are renewable. They're reliable because they are not dependent on the weather, or not really dependent on the weather anyway. Obviously if you have an incredibly dry spell then it's possible that the water in the reservoir may run out, but we should be pretty confident that we can class them as being reliable. They're certainly more reliable than some of the other sources that we're going to look at. And of course it is renewable because the fuel is never going to run out. Hydroelectric power stations do not use fossil fuels and so preserve these fuels for other uses. They don't produce any carbon dioxide and so will not contribute to global warming. The disadvantages of this is that it may destroy habitats when they are being constructed. The destruction of habitats can of course reduce biodiversity in a certain region. They of course look quite ugly as well, and so we say that they can cause visual pollution. Now let's consider wind turbines then. I'm sure everyone's seen a wind turbine at one stage or another. Let's consider how it works then. The wind turbines, the wind turns the blades of the turbine by simply just blowing. The kinetic energy of the wind is going to make those blades rotate. The turbines, once they are rotating, will then spin a generator, and that generator of course will then produce electricity. The advantages of this are that wind turbines of course have no fuel costs. The wind is alas free. Wind turbines are renewable. We are never going to run out of wind. Wind turbines do not use fossil fuels and so preserve these fuels for other uses. They don't produce carbon dioxide and so do not contribute towards the effects of global warming such as rising sea levels. Neither do they produce sulfur dioxide, which will cause acid rain. Disadvantages: wind turbines are unreliable because it is not always windy. You are literally dependent on the wind and the wind speed, so therefore we cannot have a guaranteed power output. Lots of wind turbines are needed because they do not efficiently convert the wind's kinetic energy into electricity. Now let's look at tidal barrages then. So a tidal barrage is a dam-like structure used to capture the energy from masses of water moving in and out of a bay, a river or an estuary due to tidal forces. Of course the tides being caused by the position of the moon. When the tide comes in, water is trapped behind what we call sluice gates. You can see those labelled on the board. So the tide will come in, meaning the water level will rise in the tidal basin. Those sluice gates then get lowered to trap the water for when we need electricity. When energy is needed, the sluice gates are raised and the water will then flow back out. When that flowing water goes out, that turns a turbine, and of course a turning turbine will spin a generator, and that will produce electricity. The advantages of using a tidal barrage are, of course, there are no fuel costs, the tides do not cost us any money, and they are not going to run out either, so we can say that they are renewable. They're also reliable. We can predict when the tide is going to come in and when it is going to go out, so we're not dependent on anything. Tidal barrages do not use fossil fuels and so preserve these fuels for other uses. They don't produce carbon dioxide and so don't contribute towards global warming and its effects. They also, of course, don't produce any sulfur dioxide, SO2, and so will not contribute towards acid rain. The main disadvantages of this is that it can cause damage to animal habitats when they are being constructed in a river estuary. Therefore, that can affect biodiversity and cause it to reduce. Solar panels, certainly if you go for a walk around most estates now, you'll see at least one house that has solar panels on it. Solar panels absorb energy that is being transferred by light, and that will heat up water inside solar panels. The solar panels are usually painted matte black because matte black surfaces are the best absorbers of infrared radiation. The advantages of using solar panels are, of course, that they have no fuel costs, they are renewable, solar panels do not use fossil fuels and so preserve these fuels for other uses, they don't produce carbon dioxide and so will not contribute towards global warming. The disadvantages are that solar panels are, of course, unreliable because they depend on the amount of sunlight available. During maybe June, July, August, we might get high levels of sunlight, and so this will be a very, very good way of generating electricity. But during the winter months, when we typically have a lot more cloud cover, the sun isn't up for as long, then we would not be able to generate electricity for as long. A second disadvantage is that solar panels are not very efficient at transferring the energy that is transferred by radiation into the thermal energy of the water. Okay, I've got a task for you to do now then. We've talked about the various ways that we can generate electricity, and one of them that we discussed was, of course, wind turbines. I would like you to have a go at thinking about the advantages and disadvantages of building wind turbines offshore as opposed to building them inland as shown in the pictures on the board. I would like you to come up with a minimum, please, of 2 advantages and 2 disadvantages for building them on land and building them at sea. Pause the video, write down your answers in as much detail as you can, and then press play to check your work. So, let's first of all consider the advantages of building them offshore. Well, if we build them offshore, that is typically where we will have a higher average wind speed, and that means that the turbines will be spun quicker and more likely to generate more electricity. So the first marking point you could say is that offshore we would have a higher average wind speed or faster wind speed. It's easier to transport large components to the site because obviously you're not limited by space in any way when you're working out at sea, and it doesn't matter about the noise created by the wind turbines. If you ever stand near a wind turbine, you'll know exactly what I mean by that. They are, of course, very loud. Building them inland, the noise will cause quite a lot of problem. We will class that as noise pollution. You could also have had a mark as well for reference to visual pollution not being an issue when they are built at sea. But of course there are disadvantages to building them at sea as well. The disadvantages of building them at sea is that long transmission cables are needed to get the electricity from the offshore wind turbines to the land where it's going to be used. And of course they are a navigation hazard for boats as well, because if a boat crashes into a wind turbine, not only will the wind turbine get damaged, but the ship will be damaged as well, which potentially puts human lives at risk. Okay, another task for you to do to consolidate your knowledge. We've got on the board 2, 4, 6, 8, 10, 12 different keywords. I would like to have a go at doing a target board activity, please, using these 12 keywords. If you're not familiar with a target board activity, it essentially means making bullet point sentences where you will be using a minimum of one of these words, but ideally you will be using more than one of these words. You then have to keep on writing bullet points until you've used all of the word at least once. You can use the words more than once, of course. Pause the video and make a bullet pointed list of all of these words used in sentences correctly. Okay, so now that you've had a go at doing that, I'm just going to provide you with some examples of things that you could have said. You could have said, for example, that biofuel and tidal barrages are renewable sources of energy, and that would have included 3 words: biofuel, tidal barrage, and renewable. You could also have said instead that nuclear power stations or nuclear fuel, which is uranium, has a high energy density. That again gets 3 words in there.